Now we're going to take a look at simplifying rational expressions that maybe looks a little bit more familiar to you than what the first video was. So we're just going to cancel our common factors. On part A, we've already got it factored out so that it's all multiplication. You cannot cancel until it's factored form, which if it's all multiplication, then it's factored form. So 15 and 10 have a common factor of 5. We're going to divide each of those by 5. X squared divided by x is x. Y cubed divided by y squared is y. So our simplified expression is 3xy over 2. Second piece is we are going to state the domain again. Now when we're looking at the domain, we have to look at the original expression, not the simplified form, because originally x and y were both in the denominator, which means neither one of them can be equal to 0. Even in our simplified expression, x and y cannot equal 0. All right, part B is not factored. Our numerator, x squared minus 25, is a difference of squares, so we can factor that as x minus 5, x plus 5, all over 5 minus x. Now 5 minus x isn't exactly the same as one of the binomials in the numerator, but maybe I could factor out a negative and get it to match. So we factor that negative out and we get negative 5 plus x, which is the same thing as x minus 5 if we were to switch those around. So we can, because now it's in factored form, cancel our x minus 5 with our x minus 5 in the denominator, and then we'll have that x plus 5 divided by negative 1. So our simplified expression is that negative x minus 5, and the domain restriction, we have to go back to the original expression. 5 minus x was in the denominator, which cannot equal 0, which means x cannot equal 5. We're going to look at some more that are similar to that. Now on part C, what I've seen students do in the past is they see that x squared divided by x squared and cancel them out right away. So notice my big warning in red over here. Beware of the common mistake of canceling before factoring. Let's simplify this and see we had 5 minus 7 over 5 plus 3. Order of operations tells us that fraction bar is a grouping symbol, and we have to subtract in the numerator and add in the denominator first before we divide. 5 minus 7 is negative 2 over 8 is negative 1/4. Well, now let's look at that if we canceled those 5s, like a lot of people try to do when it's a variable. Well, if we cancel the 5s, we end up with negative 7/3, which most definitely is not equal to negative 1/4. So I hope that I have showed you that you cannot cancel before you factor. So let's get this out of the way so that we can factor and finish simplifying this expression. All right, so both of these are t-charts. So we are going to think about what multiplies to 12 and adds to negative 7. Negative 3, negative 4. In the denominator, what multiplies to negative 18 adds to positive 3, positive 6, negative 3. So our x minus 3's cancel, leaving us with x minus 4 over x plus 6. Domain restrictions. Looking at the original factored form, x cannot equal negative 6. That would make this equal to 0, and x cannot equal 3. That would make that equal to 0. One more, let's take a look at the factoring. We can factor an x out of the numerator. In the denominator, we've got t-chart, what multiplies to negative 2 and adds to 1, positive 2, negative 1. Now this might look like it doesn't simplify. However, that x squared minus 4 is a difference of squares, so we can keep factoring. And of course, now those x minus 2's cancel, leaving us, the x plus 2's cancel, leaving us with x times x minus 2 all over x minus 1. Domain, look at the original factored form before you canceled. What's in the denominator? X cannot equal negative 2 or positive 1.